So you have several. For instance, we know already, last time we looked at the function w equal x, y, and z. So we have a function of 3 variables, if 3 independent variables, but perhaps we can have n intermediate variables. Each intermediate variable has m independent variables. So instead of st, you have as many as you want. So instead of, because we are at the risk of running off letters, we're going to let all the intermediate variables to be x1, x2, x3, all the way to x sub n. And all the independent variables, instead of st and so on, we call them t1, t2, t3, and until we get to t sub m. Now, we don't necessarily have the same number of intermediate variables and independent variables. So that's why we have n and n. So let's write, and let's see what comes at the end of it. So the general case is the following. So suppose instead of z, we'll use u. U is a function of x sub 1, x sub 2, dot, 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 x sub n. And suppose x sub I, any given x sub I, is another function, and you have different functions for different, no, it's, we call it as g of. No, it's a function because not necessarily the same function. So it's made of a function of what? We have t sub 1, t sub 2, dot, 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 t sub m, like so. Okay? And all the functions are differentiable in a similar fashion as in case 2. Then the partial derivatives of u are given by the following. So we're going to say that in the general case we have del u del t sub I, that particular independent variable, we're going to be written as del u del x sub 1 times del x sub 1 divided by del x sub 1 derived with respect to this particular independent variable t sub I, and then we go del u till del the second intermediate variable x2 times the derivative of x2 with respect to that independent variable, and all the way to we get to the end, and then we'll have del u del x sub n multiplied by the derivative of x sub n with respect to that particular independent variable t sub I. And all we need to say here, where I will go from 1 to what? M, because that's how many independent variables we have. And now we are ready for an example. What do you think? I think it's n. We talked about x sub n. We have n intermediate variables and n independent variables. Okay, so here's an example. So I'll pick up an example. W equals x cubed minus 2xy plus 3yz squared. Okay, and now we need an expression for x, y, and z in terms of s and t. So, unlike what I did in the morning, I kind of had to wing this example. I didn't have that ready. So, I'll make a little simpler example. I'm going to say that x equals cosine of t, y equals e to the st, and z equals 2s squared t cubed. Okay? And what we need to find, so we have two independent variables, three intermediate variables. We need to find del w, del s, and del w, del t. Are you guys okay? I thought I heard the door or something. All right. So, how many components we are after? I thought 9. Let's see. We need to have del w, del x, del w, del y, del w, del z. This is right. This is 3. And then del x, del s, del L, 6 more, because we'll have del x, del s, del x, del t, and then del y, del s, del y, del t, del z, del s, del z, del t. So 3 partial derivative with respect to the intermediate derivative, and 6 more with respect to the independent variables. I'm sorry, I said intermediate derivative. I meant intermediate variables. So let's work on this one. Okay, so page 3 will give us the solution. Let's write first of all the structure of the solution. Okay. So we are looking for del w, del s. Well, it will be del w, del x, del s, plus del w, del y, del s, and del w, del z, del s. Right? And then del w, del t have the same structure, so we're going to reuse del w, del x, but then we'll have del x, del t, and so on. Now, some of these terms won't exist, of course, but we'll see it in a minute. So, total of 9. So, let's start with the partial derivative with respect to the intermediate variable. So, del w, del x. So, we're looking back at the function. So, the derivative with respect to x, we have 3x squared, and then minus 2y, and that's it. Okay. The other term is del w, del y. So 0, and then we have negative 2x, and then we have 3z squared. And then del w, del z, 0, 0, and then we have simply 6yz. Okay? Make sure that I didn't make any mistake here. And then, now we need to take the partial derivative, del x, del s, del y, del s, and so 6 more coming now. Okay? So look at the x and y and z and start taking the derivative. So we start with del x, del s. Well, that's 0. Okay, del y, del s. Well, it's going to be what? T is a constant, so it will be t e to the st. I mean, we hold the other variable as a constant. And del z, del s will be 4s t cubed. And we'll repeat that this time with respect to t. So it will be negative sine t, del x del t is negative sine t, del y del t is s e to the st, and del z del t equals what? 6s squared t squared. And now we need to put it together. We got 3 and 6, total of 9, and then assemble them. So the partial derivative with respect to s, okay, we have 3x squared. Okay, but before we go there, there is one more thing that we need to do. Okay, at the end, we need to express the partial derivatives in terms of the independent variable s and t. Okay? We cannot have x and y anymore, x, y, z at this time. Okay? So we need to express the three the three partial derivatives with respect to x, y, and z in terms of s and t. So x is what? It's cosine, right? So we have 3 cosine squared of t minus 2y, and y is e to the st. Okay, here we have minus 2 cosine t plus 3z squared, so plus 6 s squared t cubed, and this one 6y times z, so we have 6 times 2, so that would be 12 e to the st, and leave it at the end. Z is s squared t cubed and e to the st. I always like to keep the exponent at the very end. And now I'm ready to write, to finalize the solution. So I'm looking on top right here, del x del y now will be del x del w del x, sorry, is 3, the quantity 3 cosine squared of t minus 2 e to the st times del x del s, which is right here, which is 0. Negative 2x. Let's see. X is cosine, so that's okay. And now 3z squared. Oh, yeah, you're right. 3 times 4, so that would be 12. Thank you so much. It's z squared, so I did not square, so it's 3 times z squared is right here. I'm sorry, this is z. So we squared, it's 4s squared, s to the 4th, t to the 6. Right? So 12 s to the 4, t to the 6. Anything else? That's the only time we have the z squared. All right. It didn't affect this solution plus. It's 0 anyway. So the first component is 0. Now we go to del w del y. Now would influence this part. So we have negative 2 cosine t. Actually, let me write it here below, underneath. Okay. I do plus dot dot, and then I write it below. So we have negative 2 cosine t plus 12 s to the 4th t to the 6th times del w del s. Well, del w del s is right here, t e to the st. Okay, and the third term is del w del z, which is this thing, 12s squared t cubed e to the st, multiplied by del z del s, which is right here, 4 st cubed. And I'm not going to clear the parentheses, and there's something that you can do later on. Now we'll do del w del t. Again, I need del w del x, which we have already. So it's this quantity, 3 cosine squared t minus 2 e to the st, times, this time, del x del t. Well, del x del t is negative sine t. Del w del y hasn't changed. And del y del t is s e to the st. And finally, the last component, del w del z, 12s squared t cubed e to the st, and we multiply it by del z del t, which is, I lost it, where is it? Right here, 6s squared t squared. Okay. And I'm going to stop here. Now, what happened is we can evaluate it for a specific value of s and t, and that will make it a little bit shorter had I given you a specific value, because then some of the expressions, especially if I tell you that where is the, we have cosine, right? So if I gave you t equals pi over 2, that kind of killed the cosine right away. And make everything a little bit simpler.